So we've looked at the theory behind writing improper algebraic fractions in terms of partial fractions. What we're going to look at today, I'm going to give you a couple of examples of this. I want you to have a crack at these examples after pausing the video, then come back and check your answers and work in with the working I'm going to present here. Your two questions that I'm going to give you then are these two here. So right now, pause the video, have a ping at them, come back, see how you get on. So the first question, I've got x cubed plus 4x squared minus x plus 2 over x squared plus x. Now first thing to look at is the highest power on top, highest power on the bottom. Top outweighs the bottom, so I've got improper fractions. First thing I need to do is do a bit of algebraic long division in order to eliminate that. So I've got x squared plus x on the outside. Underneath I've got x cubed plus 4x squared minus x plus 2. And I go through it the same way I go through it in all the steps and all the examples that I've shown you in the past. So I take my x squared into x cubed, and I get x, and then multiply everything here by the x, and I get x cubed plus x squared. I then subtract it down to get rid of the highest powered term, and I end up with 4x squared take away x squared. So I get 3x squared because the x cubed part all disappears. I've then got minus x plus 2. Now the highest power here is the same as the highest power there, so we've got to go one more step to get rid of it, and it's the same steps. X squared into 3x squared gives me plus 3 there. Then go back and multiply the whole thing by it, and I get 3x squared plus 3x. And I do the same thing, subtract them. 3x squareds disappear, minus x take away 3x gives me minus 4x, and then I've got plus 2. Great, so when I do the division, this is going to be essentially what would be the equivalent of a whole number part when you do a division involving numbers. What I've got here is the remainder, and this is going to be written in the partial fraction terms. So now my focus switches to this, because what I've got to do now is figure out how to express minus 4x plus 2 over the x squared plus x in partial fractions. Well, first thing to do is actually factorise the bottom, so a common factor between them. So I've got x bracket x plus 1. What this then does is if I look at it, I've got distinct linear factors here. Now, I know all the examples have been x plus a, x plus b and so forth. Well, this one here, x technically is x plus 0, so it does have its own fraction. So I split it up and I'll get a over x plus b over x plus 1. And now I do the exact same as I've always done to figure it out. Multiply and get rid of the denominator, so multiply everything by x bracket x plus 1, substitute in values of x, and find my a and my b. So multiplying through by that, I get negative 4x plus 2 equals a times the x plus 1 part, plus b times the x. Then I pick values of x to get rid of these terms and find the alternative, and then I can write my answer out. So if I choose x equals negative 1, what I'm going to do there is I'm going to get rid of the a part here, and I'll be able to find b. So I get negative 4 times negative 1, which is 4, plus 2, which is 6, and that equals b times negative 1, so negative b. So from that, I can state that b is equal to negative 6. I'm then looking to get rid of b so I can find my a. Well, if I choose x equals 0, the b disappears. Now remember, at this point, because I have the value for b, I could pick any value for x I wanted. Just try and keep it as simple as you possibly can. So I've put x equals 0 in here. I end up getting 2 left on this side, and then I get 0 plus 1, so I end up getting a. So I know then from that my a is equal to 2. So I've got my a and I've got my b here. Now I've got to write the entire thing out as the question once. So what I can say, find I've got my x cubed plus 4x squared minus x plus 2 all over the x squared plus x, so the original function itself. What I then do is I express that in terms of the answer from the division, then adding on the partial fractions. So what that would be expressed as is x plus 3, then my two partial fractions together. So I'd have plus 2 over x, so the a over x, and then my b over x plus 1, so negative 6, so it would be minus 6 over x plus 1. So there you go, answer for the first one. That's it expressed in partial fractions, and I've got this extra part here, essentially the equivalent of what would be a whole number, if you like, if we did it with numerical values. Second example is this one here. So I've got x to the 4 plus 2x squared minus 2x plus 1 over x cubed plus x. So again, compare the powers. I've got x to the 4, x cubed here, higher on the top, so I have to do algebraic long division. Quick thing to note, if you look at the top, I've no x cubed term here. I'm missing that. And if you look at the bottom, I'm actually also missing an x squared term from here. So we've got to take that into account when we do the algebraic long division. So what you would do here, keep the numbers outside. You've got your x cubed plus x. Don't worry too much about that. But when you do this one, and I've got x to the 4, add in 0x cubed. Helps it to line up, and again, it just avoids some confusion that some people get when they do it. I've then got my plus 2x squared minus 2x plus 1. And then I can go through it as normal. So x cubed into x to the 4 gives me x. Multiply that through. I've then got x to the power of 4. I've got no x squareds in here, so when I multiply I don't get any x cubeds. So again, I can essentially put plus 0x cubed. Then I've got plus x squared there. Then follow the same set of steps and I subtract them. x4 take away x4 is nothing. 0x cubed take away 0x cubed again is nothing. 2x squared take away x squared gives me an x squared there. And then I've got my minus 2x and I've got my plus 1. Now look at this. My highest power here is now less than that. Great, I only have to do one step of algebraic long division. This part here, the x, that is going to be what's outside. I'm then going to have to take this remainder, focus on that, and put it into partial fractions. So what I'm going to focus on now is the remainder, the x squared minus 2x plus 1 over the denominator. Now look at the denominator. X is a common factor. So I've got x bracket x squared plus 1 on the bottom. Now I've got a quadratic part here, so we could think about factorising. But if I look at that and do the determinant, b squared minus 4ac, what I'll end up getting for that is 0 squared, because there's no x term, take away 4 times 1 times 1, and what that will give me is negative 4. So I end up with a negative determinant, so I can't factorise that. So what that means is my partial fractions are going to take the form of a over x plus the linear over the quadratic format, bx plus c over, in this case, x squared plus 1. So I'm going to have this kind of fraction here. Again though, it's the same set of steps. Multiply it by x bracket x squared plus 1 to get rid of the denominators, plug in some values, and let's see what we get. When I multiply through, I get x squared minus 2x plus 1 equals a bracket x squared plus 1 plus the bx plus c all multiplied by x. Plug in some values of x, let's find my a, b and my c. Well, if I make x 0, this all goes. So if I choose x equal to 0, what I'm left with here on the left hand side is just 1. I've then got a times 0 plus 1, which is just 1. So I know from that that a is equal to 1. Now normally we'd look to get rid of the next term, but because it's an x squared, if I substitute x as negative 1 in there, it makes it a positive, so actually this is not going to disappear. This is one of those cases where what's going to happen, we're going to have to put in two values for x, and we'll end up with a pair of simultaneous equations that we're going to have to solve. So imagine I choose x is equal to 1 first. What I'm going to get on the left hand side is I'm going to get 1 take away 2 plus 1. So I get 2 take away 2. So I'm actually going to be left with 0 on the left hand side. In here I've then got 1 plus 1, so 2 times whatever the value of a is, which we know is 1. So I've got 2 there. If x is equal to 1 here, I've got b plus c times 1. So I've then got 2 plus b plus c. So from that first one, what I know I can get is b plus c is equal to negative 2. What I can then do is substitute in a second value. So let's say x is equal to negative 1, and then take it from there to get another simultaneous equation, which I can then use together from that. So if I put x as -1 in there, I get -1 squared, which is 1. Take away 2 times -1, so that becomes +2 plus 1. So 1 plus 2 plus 1 gives me 4. I've then got -1 squared plus 1, which again is 1 plus 1, which is 2. Times it by the a, and I get another 2 there. I've then got b times -1 plus c, so I've got minus b plus c, but then I'm going to multiply that again by -1. So I'm going to end up with a plus b, but in this case, I'm going to end up with a minus c. So the second equation I get is b minus c equals 4 take away 2, which is 2. So now I have to solve these two equations to get my b and my c. Well, what I can do is if I add them, the c plus the negative c will disappear. So I'm going to end up with is 2b equals -2 plus 2, which is 0. So actually, my b is going to be equal to 0. Put it into here and I can solve it. What I'll end up getting for either of the two of them is that c is equal to -2. So I've got my b, I've got my c. Yeah, the x is going to disappear here, but that can happen. So what I can then do is go back to the original and say, fine, so my original expression, the x to the 4 plus 2x squared plus minus 2x plus 1 over the x cubed plus x, that can be written in the format of x, then it's plus a over x, which is plus 1 over x. I've then got plus the bx plus c over x squared minus 1. So b is 0, that's then minus 2, so that can then become take away 2 over x squared plus 1. So that there is then how it is. Whenever we've got an improper fraction, we'll have some form of an answer here from the synthetic algebraic long division, then adding on our two partial fractions. Remember those general steps whenever it comes to it and you'll be fine. Figure it out using the algebraic long division, then focus on the remainder and split it into your partial fractions, and then combine the whole thing together. Don't forget to write out your final answer after you've done the work.